the weight of a colour, Saturn would float, not as a metaphor, not as a way of saying it is light for its size, or that its density is lower than expected, or any other softened version of the fact. The actual fact is this: if you found a body of water large enough to place Saturn in, Saturn would sit on the surface. A planet with a diameter 9 times larger than Earth's, a planet that could hold 760 Earths inside it by volume, a planet that has been sitting in the same region of the solar system for 4.5 billion years, doing things that would be catastrophic at any human scale. That planet is less dense than water. The average density of Saturn is approximately 687 kilograms per cubic meter. Water is 1,000. The arithmetic goes in the direction it goes, and the direction is strange, and the strangeness does not resolve into comfort the longer you sit with it. This is the planet that gets described as peaceful. The light from Saturn takes approximately 70 to 80 minutes to reach Earth, depending on where both planets are in their orbits at the time. By the time it arrives, it is old light, slightly outdated, carrying information about a surface and a ring system that has already moved, already changed slightly, in the time the light spent crossing the gap. What you see when you look at Saturn is a version of Saturn that no longer quite exists. This is true of everything in the night sky, and it is true of Saturn in the specific, unhurried way that distance makes things true. Not dramatically, not as revelation, just as the ordinary consequence of how fast light goes and how far away things are. It sits in the sky as a yellowish point, or through a modest telescope as the thing that makes people stop and ask whoever is holding the telescope to let them look again, because the rings do not look real from Earth. They look like something attached to the image rather than part of it. They look like a label. The planet below them is a pale gold, banded faintly, and it is genuinely difficult to hold in mind while looking at it what the scale of the thing actually is. The scale is the problem this narration keeps returning to. Not because scale alone is interesting, scale alone is just a number, but because Saturn's scale interacts with everything else about it in ways that produce something other than wonder. Something closer to the feeling of standing at the edge of a roof, not danger, not beauty. The specific alertness that comes from being near something large that does not care. Here is what is sitting inside that pale gold point. The atmosphere of Saturn. An atmosphere is almost the wrong word because Saturn does not have a surface for an atmosphere to sit on top of. It is more accurate to say that Saturn is atmosphere for most of what we can observe, going down until the atmosphere becomes something else. The atmosphere runs winds at speeds that have been measured at up to 1,800 kilometers per hour near the equator. Earth's most violent hurricanes reach sustained wind speeds of around 300 kilometers per hour. The winds on Saturn are not storm events. They are not weather in any sense that word carries in everyday use. They are the permanent condition of the planet's outer layers, and they have been running at those speeds for as long as any instrument has been pointed at Saturn, and there is no particular reason to think they were much different before that. The winds are not the strangest thing. At Saturn's north pole, there is a hexagonal cloud formation approximately 30,000 kilometers across. Each side of the hexagon is longer than the diameter of Earth. It has been observed continuously since the Voyager spacecraft passed Saturn in the early 1980s, which is the earliest point at which we had instruments capable of seeing it clearly, and it was there then, and it is there now, and it rotates at the same rate as Saturn's interior, completing one rotation approximately every 10 hours and 39 minutes. The geometry is precise in a way that geometry in a fluid has no obvious reason to be. It is not a solid structure. It is a persistent wave pattern in a gas giant's atmosphere, and the fluid dynamics that produce hexagonal standing waves in rotating systems are understood in laboratory conditions, and the understanding does not make the hexagon feel less strange when you consider that it is sitting at the top of a planet at this moment, rotating 30,000 kilometers across, and has been there longer than any human institution. Go deeper than the atmosphere, and the word deeper starts to mean something different. As you descend into Saturn, as the pressure increases, which it does continuously and without any clear layer that marks a transition, the hydrogen that makes up most of Saturn's composition begins to behave differently. In the outer atmosphere, it is a gas, behaving more or less the way gases behave. Deeper, under pressures that exceed anything achievable in most laboratory settings on Earth, it becomes a liquid. Deeper still, under pressures in the range of 1,000,000 times Earth's atmospheric pressure, it goes through a transition that has no clean everyday name: metallic hydrogen. A state in which hydrogen, which under normal conditions is one of the least conductive elements, becomes electrically conductive, the electrons separating from their nuclei and moving freely through the material the way electrons move through metal. There is no surface inside Saturn. There is no place where falling would stop. The planet goes from gas to liquid to metallic fluid, and potentially to a rocky or icy core at its centre, and the transitions between those states are gradual and pressure-driven, and there is no boundary you would cross, no floor you would reach. The inside of Saturn is a pressure gradient from the cloud tops down to whatever sits at the centre, and the entire structure has been doing this, running its winds, maintaining its hexagon, conducting its metallic hydrogen for 4.5 billion years without interruption. The rings are the part that looks permanent. They are not. Saturn's rings are composed mostly of water ice, in particles ranging from the size of a grain of sand to the size of a house, spread across a structure approximately 280,000 kilometers wide, but in most places less than a kilometer thick. If you scaled the rings down to the diameter of a standard piece of paper, the thickness at that scale would be far less than the thickness of the paper itself. The rings are, by the standards of the solar system, almost impossibly thin relative to their width, and they are bright because the ice is clean, geologically recent, not yet darkened by the constant rain of micrometeorites and charged particles that darkens old surfaces in the outer solar system. The rings are geologically recent. Current estimates place their age at somewhere between 10 and 100 million years old, a range that sounds large until you consider that the solar system is 4.5 billion years old, which means the rings at most have been there for roughly 2% of the solar system's existence. The dinosaurs were already gone before the rings were necessarily there in their current form. Saturn existed for most of its life as a planet without the ring system that now defines how it looks from Earth, and the rings are going. Saturn's gravity is pulling them in, a process called ring rain. in which charged particles from the rings spiral down into Saturn's atmosphere along magnetic field lines. The current estimated rate of loss is somewhere between 432 and 2,870 kilograms of ring material per second, and at that rate the rings have somewhere between 100 million and 300 million years remaining. They arrived recently. They are leaving. What you're looking at when you look at Saturn's rings is something mid-process. The famous image, the thing that makes people ask to look again through the telescope, is a feature of a specific window of time in Saturn's history, and that window is open now, and it will not always be open. The Cassini spacecraft arrived at Saturn in 2004 and spent 13 years there, orbiting the planet and its moons, sending back data continuously, before its mission controllers deliberately guided it into Saturn's atmosphere in September 2017, where it burned up. The decision was made to avoid any possibility of contaminating Saturn's moons, particularly Enceladus, which sprays water ice from subsurface liquid water through geysers at its south pole, and which has therefore been identified as a place where conditions for life might exist. With any Earth microbes that might have survived the journey on the spacecraft's surface, Cassini went into Saturn on purpose. The last signal arrived at Earth 70 minutes after the spacecraft itself had gone, because that is how long the signal took to cross the distance. By the time the final transmission was received, Cassini had already been part of Saturn for over an hour. In its final orbits, the grand finale, Cassini threaded the gap between the innermost ring and the top of Saturn's atmosphere, a gap of approximately 2,000 kilometers that had never been navigated before, that was expected to contain enough debris to be hazardous, and that turned out to be nearly empty. The instruments designed to measure particle impacts in that region recorded almost nothing. The space between Saturn and its own rings was quieter than predicted, in a way that is still being processed, still producing papers, still sitting open in the data. The rings are above, the planet is below. The gap between them is, apparently, almost nothing, and nobody is entirely sure why. This is the planet that gets called the jewel of the solar system, the beautiful one, the peaceful one, the one that does not threaten the way Jupiter threatens, with its history of absorbing comets and its vast magnetic field, and its centuries-old storm the size of several Earths. Saturn is the one people seem to feel affection for, the way you might feel affection for something decorative and still. But the winds are running at 1,800 kilometers per hour. The hexagon is rotating at the North Pole 30,000 kilometers across, and has been since before the instruments existed to see it. The inside has no surface and no floor. The rings are ice that arrived late and is leaving early, and in the gap between those rings and the planet itself there is a space that should be full and is not, for reasons that are still being worked out. Saturn is not threatening in the way that something aggressive threatens. It is doing something more patient than that. It has been running its systems for 4.5 billion years, maintaining its geometry, pulling its rings slowly inward, compressing hydrogen into states that have no common name, and it will continue doing this long after the rings are gone, long after the gap has been explained, long after whatever is currently orbiting it has moved on or fallen in. The weight of that, the specific, unhurried weight of something that size operating on that time scale, is the thing that the word peaceful does not carry. It is not peaceful, it is patient. And the difference between those two things is what this narration is about. Floating is the wrong word. Saturn is mostly hydrogen. That is the starting point, and it sounds simple, and it is simple, and then it immediately is not. Hydrogen is the lightest element. Number 1 on the periodic table. 1 proton, 1 electron, the most abundant thing in the universe by a significant distance. The Sun is mostly hydrogen. Jupiter is mostly hydrogen. The gas giants are called gas giants partly because of this, because they are, in their outer layers at least, made of things we associate with gas, with lightness, with the absence of weight. Saturn is less dense than water. The number is 687 kilograms per cubic meter, and water is 1,000. And the gap between those two numbers is the thing worth staying with. It floats. Technically, hypothetically, if the body of water existed. The problem with this fact, the reason it is interesting and not just a curiosity, is what it implies about the relationship between size and density, which is not the relationship most people carry around intuitively. Large things in everyday experience are heavy, denser, more substantial. A boulder feels more real than a handful of air. Saturn's size, 9 Earth diameters, 760 Earth volumes, feels like it should correspond to a proportional mass, a proportional weight, a proportional solidity. But density is not size. Density is mass per unit volume, and a planet made mostly of hydrogen and helium, even a very large planet, even a planet with a core of rock and ice at its centre pressing under enormous weight, can come out lighter per cubic meter than liquid water. The size is real. The lightness is also real. The two facts sit together without resolving into a single comfortable image. The core is where some of the density story lives. Saturn almost certainly has a core, a region at its centre composed of rock, metal and ice, under pressures so extreme that the distinction between solid and liquid may not hold in any meaningful way. The mass of this core is estimated at somewhere between 9 and 22 times the mass of Earth, which sounds substantial until you remember that the total mass of Saturn is about 95 times the mass of Earth. The core, whatever it is, accounts for roughly 10 to 20% of the planet's total mass, possibly less. The rest is gas and liquid, and the metallic hydrogen in the deep interior spread across a volume so large that the density per cubic meter comes out where it comes out. The core is also not well understood. Cassini's gravity measurements in its final orbit suggested that Saturn's core may be diffuse, not a sharp rocky ball at the centre, but a gradual transition, a region where heavy elements are distributed across a larger volume than expected, mixed into the surrounding fluid rather than concentrated cleanly at the centre. The word used in the relevant papers is fuzzy. Saturn may have a fuzzy core, a boundary that is not a boundary, a centre that is not quite central in any clean geometric sense. This is not a settled question. The floating fact carries something else inside it that usually goes unmentioned. If Saturn floats in water, that means water is denser than Saturn. Water, the liquid that covers most of Earth's surface, that falls as rain, that the human body is mostly made of, is heavier per cubic meter than an entire gas giant. This is true. It is also, when stated that way, mildly disorienting in a direction that is hard to name, not frightening, not even particularly surprising, once you understand the hydrogen density. Just off. The categories are not sitting where the intuition placed them. The sentence where everything changes its direction without warning is this one. Saturn is the least dense planet in the solar system, and it is also the second largest, and those two facts have nothing to do with each other, and that is the point. Large and light, vast and low density, a planet that contains multitudes of Earths by volume and would still sit on top of the water rather than sinking through it. The relationship between those facts is not intuitive and does not become intuitive with familiarity. It just becomes familiar. There is one more thing the density implies, and it is the thing this chapter was heading toward. The reason Saturn's density is low, the reason hydrogen and helium spread across that volume average out to less than water, is that gas giants form differently from rocky planets. They do not accrete dust and rock into a solid body and stop. They reach a point in their formation once their rocky and icy core crosses a certain mass threshold, where their gravity becomes strong enough to pull in gas directly from the surrounding protoplanetary disk. They grow fast. They grow large. They end up as mostly the gas they pulled in rather than the rock they started with. Saturn formed this way, and the result is a planet that is mostly the lightest elements in the universe, spread across a volume that corresponds to size but not to density, and the floating fact is just what happens when you do that arithmetic. It is not wrong to say Saturn floats, but floating implies something placid, something that sits gently at a surface, rocking a little, taking up its allotted space without insistence. Saturn at that hypothetical surface would still be running its 1,800 km/h equatorial winds. The hexagon would still be turning at the North Pole. The metallic hydrogen in the deep interior would still be conducting electrical currents that generate a magnetic field 17 times stronger than Earth's. The rings would still be losing thousands of kilograms per second to ring rain. It would float, technically, at that surface. It would not be calm at that surface. Those are different things, and the difference is the reason floating is the wrong word. The noise. Underneath. There is no moment when you arrive. That is the first thing to understand about the inside of Saturn, and it is the thing that makes the inside of Saturn unlike almost any other large structure a person might try to imagine their way into. A cave, a building, a body of water. Because all of those have floors, have walls, have some surface at which descent ends and presence begins. Saturn does not have this. The descent into Saturn is a continuous process of becoming something else, and the becoming has no single step at which it is complete, no threshold that announces itself, no surface that rises to meet you. You're in the atmosphere, which begins, if it begins anywhere, at some agreed pressure level that scientists use as a reference point, because the alternative is to say the atmosphere begins where the rings end, which is close to true, but not cleanly true, and the atmosphere is cold at the top, around minus 185 degrees Celsius at the cloud level, where the ammonia ice crystals form the bands and zones visible from Earth, and the temperature and the pressure both go up as you go down, and the rate at which they go up is not uniform, is not smooth, is the result of a dynamic atmosphere that is doing things at every level, moving heat around, running its extraordinary winds, maintaining bands of different composition and temperature in a structure that has persisted for as long as the planet has existed in anything like its current form, the pressure at the cloud tops is roughly the same as Earth's atmospheric pressure at sea level. This is one of the stranger coincidences in planetary science, that the reference level used for Saturn's atmosphere happens to sit at a pressure humans would recognize from direct experience. And it does not mean anything. It is an artifact of definition, but it means that the cloud tops of Saturn are the last point in the descent at which a human body would experience a pressure it has calibrated itself to. Below that, the pressure goes up. 100 kilometers down from the reference level, the pressure has increased by several times. The temperature is climbing. The hydrogen and helium mix is still behaving as a gas, but a gas under conditions that no surface environment on Earth replicates, and the chemistry happening in those layers, the way ammonia reacts, the way ammonium hydrosulfide forms and falls as rain in some models, the way water clouds may exist at deeper levels where the temperature rises back through the range in which water is liquid, is complicated and in many places still uncertain. The winds are running through all of this. They do not stop at a particular depth. The jet streams that produce the visible banding extend deep into the atmosphere, possibly hundreds of kilometers, possibly more. The exact depth at which Saturn's atmospheric jets peter out or are sustained is one of the things Cassini tried to measure in its final orbits, using these subtle variations in Saturn's gravity field as a way of inferring how the mass was distributed. The answer that came back suggested the jets extend roughly 9,000 kilometers deep. 9,000 kilometers is more than the diameter of Earth. The middle section of the descent is where the language starts to go. Somewhere between 10,000 and 30,000 kilometers below the cloud tops, and the range is wide because the transition is not sharp. Hydrogen crosses from behaving like a gas, even a very compressed gas, into behaving like a liquid. Not a liquid the way water is a liquid, with a surface you could theoretically touch. A fluid, under pressure, without a surface, without a container, simply the state of the matter at that depth. The pressure at this point is exceeding 1,000,000 times Earth's atmospheric pressure. The temperature is in the thousands of degrees. Go deeper. At some point, and the exact point depends on the temperature profile, which depends on models that are well constrained but not perfectly constrained, the pressure exceeds roughly 2 million atmospheres, and the hydrogen does the thing that hydrogen does under those conditions, which was first theorized in 1935 by Eugene Wigner and Hillard Bell Huntington, and not conclusively demonstrated in a laboratory until recent years under extreme experimental conditions. It goes metallic. The electrons leave their nuclei. Not in the way they leave nuclei in a chemical reaction, not in the way they are shared in a molecular bond, but in the way they leave in a metal, freely conducting, flowing through the material the way electrons flow through copper when a current runs. Metallic hydrogen. The hydrogen is still hydrogen. The atoms are still there, but the electrons are now part of a sea, a collective, and the material conducts electricity the way no gas or ordinary liquid does. This is the region that generates Saturn's magnetic field. The electric currents flowing through the metallic hydrogen, driven by Saturn's rotation, and the heat flowing outward from the interior, produce a magnetic field through the same mechanism that produces Earth's magnetic field in its liquid iron outer core, the dynamo effect, moving conducting fluid generating a magnetic field that the motion of the fluid then reinforces. Saturn's magnetic field is weaker than Jupiter's, but still about 578 times stronger than Earth's, and it is unusual among the planets of the solar system in being almost perfectly aligned with Saturn's rotation axis, within less than 1 degree. Which is odd enough that it has generated its own body of theoretical work trying to explain why. The interior is doing all of this quietly, in the sense that it produces no visible surface expression of most of it, no eruptions, no obvious signs from outside that anything is happening in there. The winds run, the bands persist, the hexagon turns, and underneath all of it, tens of thousands of kilometers down, in material that has no common name in any human language, because humans have never encountered it under normal conditions, currents are going through metallic hydrogen, and those currents are making the magnetic field that shapes the environment for hundreds of thousands of kilometers around the planet, deflecting the solar wind, creating the magnetosphere that the rings and moons and the spacecraft we sent there all live inside. There is probably a core at the center, the models suggest it. The gravity measurements lean toward it, a region of rock and ice and metal, compressed under pressures that make the word solid feel inadequate. Not because solids cannot exist at those pressures, but because the distinction between solid and liquid under extreme pressure and heat is not the same distinction it is at the surface of the Earth, and the core of Saturn may be a region where that distinction has stopped meaning what it means here. The fuzzy core, as the papers describe it, rock and heavy elements distributed through a larger volume than a clean sharp ball would occupy, mixed into the surrounding fluid in a gradient rather than concentrated at a point. A centre that is more central than the rest but less defined than the word centre implies. Whatever is down there has been down there for 4.5 billion years, under pressures that have not changed in any meaningful sense in that entire time, doing whatever it is that a planetary core does when the planet has long since finished forming and has just been running ever since. The inside of Saturn is continuous in a way that is hard to sit with. It goes from the cold ammonia clouds at the top, through the increasing pressure and temperature, through the liquid hydrogen, through the stellic hydrogen, down to whatever the core is, without a single clean boundary, without a flaw, without a place where something ends and something else begins. It is one thing, varying continuously for 60,000 kilometers in every direction from the center, and it has been this one continuous varying thing, running its currents and its winds and its slow heat loss, since before the Earth's continents had their current shapes, since before the first complex life appeared on Earth, since before almost anything that exists now had begun to exist. The inside of Saturn does not know anything has changed. A hexagon, with no explanation that satisfies. From far enough away it looks like a marking, not a storm, not a weather pattern, a marking, the way a symbol is a marking, as if something deliberate had been placed at the top of the planet to indicate something about it. 6 sides, each one approximately 13,800 kilometers long. The whole structure sitting at 78 degrees north latitude, centered on the pole, rotating in the same direction as the planet, completing one full rotation in approximately 10 hours and 39 minutes, which is, not coincidentally, because nothing about this is coincidental, the same rotation period as Saturn's interior. The Voyager 1 spacecraft photographed it in 1980. Voyager 2 photographed it in 1981. When Cassini arrived more than 2 decades later, it was still there, same shape, same location, same rotation rate. When Cassini made its final orbits in 2017, the hexagon was still there. It is there now, presumably at this moment, 30,000 kilometers across, at the North Pole of Saturn, rotating. Weather patterns on Earth do not persist for decades. The largest, most stable atmospheric structures on Earth, the polar vortex, the jet stream, shift and wobble and change on timescales of years at most. The hexagon has been observed for nearly half a century, and the observation period is limited only by when humans first had spacecraft capable of seeing it. It was almost certainly there long before that. The orbit around the central fact, geometry this precise, does not usually come from fluid dynamics. Geometry in fluids is usually approximate. A vortex is roughly circular, not exactly circular. A wave pattern tends toward regularity but tolerates variation. The hexagon at Saturn's North Pole has internal structure, smaller vortices embedded within it, a large cyclonic storm at the pole itself, and yet the outer boundary maintains its six-sidedness with a persistence that fluid dynamics can produce in laboratory conditions, but does not usually produce at planetary scales for planetary durations. Laboratory experiments have produced hexagonal wave patterns in rotating fluids. You can fill a cylinder with water, put a smaller rotating cylinder inside it to simulate differential rotation, and under the right conditions a hexagonal standing wave appears at the interface. The physics is understood. The phenomenon is a type of wave called a Rossby wave, a planetary wave driven by the variation in the Coriolis effect with latitude, and the hexagonal form is what certain Rossby waves do when the rotation rates and fluid properties are in the right relationship. The physics is understood. And yet, what the laboratory cannot replicate is the scale, or the duration, or the stability. The hexagon on Saturn is not a small laboratory curiosity scaled up. It is a feature of a planet-sized rotating fluid system that has maintained its geometry through conditions, seasonal changes in solar illumination, changes in the chemistry and cloud structure of the atmosphere, the constant perturbation of the winds running below it, that should, in any intuitive sense, have blurred its edges, shifted its phase, introduced some irregularity into its corners. The corners are not irregular, the sides are not blurred. Cassini's instruments observed the hexagon in different wavelengths, in different seasons over 13 years. The structure persisted. The internal vortices changed. Smaller storms appeared and disappeared within the hexagon, were absorbed by it, were expelled from it, but the hexagon itself did not change in any fundamental way. It rotated, it maintained its form. The cyclone at the center, roughly 4,000 kilometers across, sat there at the pole and spun. The orbit returns to the same place. Why does a standing wave in a gas giant's atmosphere maintain hexagonal geometry for a time period that exceeds any reasonable comparison from Earth's atmosphere? The answer from the physics is because the conditions that produce it are stable, because the rotation rate is stable, because the differential rotation between the pole and lower latitudes creates a sustained wave pattern that locks into this geometry. The answer is technically correct. It does not quite land. There is a detail in the Cassini observations that went relatively unreported outside the scientific papers. the colour of the hexagon changed. Between the early Cassini observations and the later ones, across the roughly 13 years of the mission, the interior of the hexagon shifted from a bluish tint to a more golden one. The change was attributed to seasonal effects. Saturn's north pole was in winter darkness during the early Cassini years, and as the northern hemisphere moved towards summer, the increase in ultraviolet radiation from the sun changed the chemistry of the upper atmosphere, producing the haze particles that give Saturn's atmosphere its golden colour. In winter, without UV, the haze was absent, and the blue came from the scattering of sunlight at shorter wavelengths. The hexagon changed colour as the seasons changed. It maintained its shape while its colour went. There is something in that, in the image of a structure that holds its geometry while its appearance shifts, that persists through seasonal cycles while the light it reflects changes, that the physics explains without fully accounting for. The explanation is accurate. The strangeness is still there underneath it. The orbit will not land because there is no landing. The hexagon is real. The physics that produces it is understood at the level of mechanism. The mechanism produces the geometry, and the geometry persists, and the persistence is a function of the stability of the conditions that produced it. None of that is in dispute. All of it is correct. What is not fully resolved, what the orbit keeps returning to without touching down, is why this particular set of conditions has stayed this stable for this long at this scale. Saturn has been in approximately its current configuration for billions of years, and the differential rotation that drives the hexagonal wave has been present throughout that time, which means the hexagon may be very old indeed, far older than the 40-odd years of human observation. It may have been there since Saturn reached its current size and rotation rate. It may have been there, 30,000 kilometers across and six-sided and turning for hundreds of millions of years. The Voyager photograph from 1980 did not discover the hexagon. It documented something that was almost certainly already ancient. What was there before the photograph is the same thing that is there now. That is the thing this chapter keeps circling without quite saying. Not that the hexagon is strange, but that it was strange for so long and alone before anything was watching. The rings were not always there. Something has already happened. The rings exist. They are there right now, overhead if you could see through the atmosphere, catching sunlight at whatever angle Saturn is currently tilted toward the sun, bright and cold and thin and present. This is the aftermath. The event that made them is over. All that is left is the consequence, slowly unwinding. The rings are made of water ice, almost entirely. Particles from specks up to chunks the size of a small building, all orbiting Saturn in the same plane, all moving at speeds calibrated by their distance from the planet. Faster in the inner rings, slower in the outer ones, all individually following the same orbital mechanics that everything in orbit follows. And the collective effect of that many individual orbits is a structure that looks from a distance like a solid disk, but is, up close, a vast collection of individual pieces that have not touched Saturn and have not touched each other in any permanent way, and are slowly, continuously losing ground. The rings are called a ring system. They have sections with letters, the D ring, the C ring, the B ring, the A ring, and several more diffuse structures beyond. The B ring is the brightest and densest. The Cassini division, named for Giovanni Cassini, who observed it in 1675, is the large gap between the B and A rings, kept clear by the gravitational influence of Saturn's moon Mimas, whose orbital period is in a 2-to-1 resonance with the orbital period of particles at that distance from Saturn, so that anything in that gap gets a gravitational nudge at the same point in every orbit, and the nudges accumulate and the gap stays empty. The rings are orderly. The gaps are orderly. The whole structure is the result of orbital mechanics doing what orbital mechanics does over a very long time. They just have not been there very long. The age question settled, more or less, with Cassini's data. The rings are young. 10 to 100 million years old is the current estimate, with the lower end looking more likely as the data is refined. The solar system is 4.5 billion years old. Saturn is 4.5 billion years old. The rings are at most 2% of the age of the system they orbit in, and possibly much less than that. The planet has been there for billions of years. The rings arrived late, in geological terms very late, like a feature added to something that had been finished for a long time. The youth is written in the brightness. Old surfaces in the outer solar system are dark. Micrometeorites, charged particles, and radiation all work to darken icy surfaces over millions of years, a process called space weathering. Saturn's rings are bright, surprisingly bright, brighter than they should be if they had been collecting that darkening for billions of years. The brightness says new ice, clean ice, ice that has not had time to accumulate the damage that time accumulates. What made them is not settled. The leading candidates involve a moon, or several moons, or a moon and a comet, that came too close to Saturn and was broken apart by tidal forces, the same forces that pull ocean tides on Earth, but operating at a scale where they can dismantle a solid body of ice and rock. The debris spread out into the ring plane. The ice is what remained. Whatever it was is gone. No trace left. The rings are going now. Ring rain is the name for the process, which was predicted before it was observed and confirmed by Cassini's instruments. The rings are not static. They interact with Saturn's magnetic field and with the solar wind, and charged particles from the rings, water molecules and ice grains that have become ionized, that have acquired a charge, follow the magnetic field lines down into Saturn's atmosphere. They fall in. Not all the material, not quickly but continuously, at a rate estimated between 432 and 2,870 kilograms every second. Every second. At the lower end of that rate, the rings have about 300 million years remaining. At the higher end, closer to 100 million years. Either way, the rings are a temporary feature. They arrived late. They are leaving on a time scale that is long by human standards and short by planetary ones. The pulse contracts here. The rings, right now, the specific rings that exist at this moment, that Cassini spent 13 years documenting, that appear in every photograph Saturn has ever been in. In 100 to 300 million years, something will still be there. Trace rings, a faint remnant, the D ring close to the planet which may persist longer. But what is there now? The bright distinctive rings that make Saturn the thing people ask to look at twice through a telescope. That is a window. The window is open. The window will close. You are looking at Saturn during the window. That is not nothing. It is, from a certain angle, the specific timing of this that is hard to hold without feeling something that is not quite wonder, and not quite loss. The rings were not there for most of Saturn's history. They will not be there for most of what remains of it. They are there now, in the few 100 million years that they exist, and this particular moment inside those few 100 million years is when human eyes first learned to see them and started sending machines to look more closely. The rings existed before anyone looked. They will be gone before the universe is done. In between, in this thin slice, something paid attention. The pulse expands again because it has to. The moons are part of this story, and the moons are also changing. Enceladus, which geysers water ice from a subsurface ocean, is actively contributing material to Saturn's E-ring through those plumes. It is both a moon and a source, a body losing mass into the ring system it inhabits. Titan, Saturn's largest moon, is slowly spiraling outward, moving away from Saturn at about 11 centimeters per year, the way the moon is moving away from Earth. The whole system is in motion, everything shifting on timescales that dwarf human history. The rings arrived. The rings are leaving. The moons are drifting. The hexagon is turning. The winds have been running for longer than anything alive has been alive. Saturn in 100 million years will still be Saturn. Same mass, same composition, same metallic hydrogen interior, same magnetic field. But it will look different from a distance. The distinctive silhouette, the feature that makes it immediately recognizable, will be reduced to something thinner, fainter, less definitively there. What we are looking at now is the version. Not the only version, not the permanent version, but the version that existed during this narrow band of time when humans happened to be here, and happened to look up and happened to have the technology to look more closely. The rings are beautiful in the specific way that things are beautiful when you know they are mid-process, not finished, not permanent, just there, right now, catching light. 17 moons are not enough to make it feel known. Titan is in the middle of doing something to its atmosphere. This is where we begin, not with the number of moons, not with an inventory, but with the specific ongoing fact of Titan and its nitrogen atmosphere and its methane cycle, which replicates, in all the broad structural features, the water cycle on Earth, except the temperatures are around minus 179 degrees Celsius, and the liquid running in the rivers and filling the lakes is not water but liquid methane, which is a natural gas at Earth's surface temperatures and is a clear liquid at Titan's surface temperatures, and the rain that falls from Titan's orange haze is methane rain, and the seas near Titan's north pole, Ligeia Mare, Kraken Mare, Punga Mare, are liquid methane and ethane, sitting still in the Cassini radar images with a smoothness that indicates no wind ripples, the calmest surfaces observed anywhere in the outer solar system. Titan is larger than the planet Mercury. If it were orbiting the Sun directly rather than orbiting Saturn, it would be classified as a planet without hesitation. It has a dense atmosphere, denser in terms of surface pressure than Earth's, and complex organic chemistry happening in its upper atmosphere, where ultraviolet radiation from the Sun breaks apart nitrogen and methane molecules, and the fragments recombine into longer molecules, tholins, a class of complex organic compound that gives Titan its orange colour and that settles slowly through the atmosphere to coat the surface. Tholins have been found in laboratory simulations to include amino acid precursors. This does not mean life. It means the chemistry is complicated in the direction of complicated chemistry. Enceladus is 250 kilometers across. At that size, most moons are cold, geologically dead, cratered remnants of the solar system's formation. Enceladus is venting water vapour and ice particles from fractures at its south pole, fractures called tiger stripes because they appear as four roughly parallel lines in the surface, each around 130 kilometres long. The venting goes hundreds of kilometres into space. The material feeds Saturn's E-ring. Beneath the ice shell, which is between 4 and 40 kilometres thick depending on location, there is a global liquid water ocean, confirmed by Cassini measurements of the Moon's slight wobble as it orbits, a wobble consistent with a decoupled shell sitting on a liquid layer. The ocean is salty. It contains silica nanoparticles that are consistent with water-rock interactions at hydrothermal vents on the ocean floor. Molecular hydrogen has been detected in the plumes, which is consistent with ongoing hydrothermal activity. The conditions that exist at Earth's hydrothermal vents, hot, mineral-rich water, chemical gradients, the kind of environment where some of Earth's earliest life is thought to have existed, appear to exist at the bottom of Enceladus's ocean, in the dark, under the ice, around a moon that from a distance looks like a small, unremarkable white ball. The tiger stripes vent. The ocean sits below. The hydrothermal vents may be active at the bottom of that ocean right now, in this moment, as Saturn rotates and the hexagon turns, and the rings lose their thousands of kilograms per second. Then there are the others. Mimas, with its enormous Herschel crater that makes it look disturbingly like a designed object. Dione, with ice cliffs and a possible subsurface ocean of its own. Rhea, Tethys, Iapetus. Iapetus with its two-toned surface, one hemisphere black as coal and one hemisphere bright as snow, a contrast so extreme that Cassini was the first person to see it in 1671, and he concluded that one side must simply be invisible in the darkness. The answer is dust. Iapetus sweeps up dark material from its leading hemisphere as it orbits, and that dark material absorbs more sunlight and drives further sublimation and redistribution of ice, amplifying the difference over millions of years into something that looks deliberate but is just physics running in one direction for a very long time. Hyperion, which tumbles chaotically. Its rotation is genuinely chaotic, not periodic, not predictable, because it is large enough and non-spherical enough and close enough to Titan's gravitational influence that its rotation state is sensitive to initial conditions in a way that makes long-range prediction impossible. Hyperion does not have a fixed day. Its poles wander. Prometheus and Pandora, shepherd moons that orbit on either side of the F-ring and maintain its narrow structure through gravitational herding, their orbits so close to the ring that they produce visible waves and clumps and distortions in the ring material as they pass. 83 confirmed moons as of recent counts, though the number changes as smaller moons are discovered. The sediment of that number takes time to settle. 83 distinct bodies, each in its own orbit, each with its own interior state and surface history, and relationship with the planet pulling at it. Most are small, irregular captured objects, dark and cold and ancient, holding orbits that are tilted and elongated and unlike the neat circular orbits of the inner moons. Some are less than a kilometre across. They are moons only in the technical sense of being natural objects in orbit. And yet, 83. many of them discovered with Earth-based telescopes by looking very carefully at a region of sky and identifying very faint moving points against the background stars and confirming the orbit and adding another moon to the count. Saturn is not a planet with a ring system and a handful of moons. It is a system. It occupies a volume of space roughly 1 million kilometers in every direction, where the planet's gravity organizes everything: rings, moons, ring particles, dust, the debris field of geological processes happening on Enceladus right now, into a structure that is, from a sufficient distance, coherent. From inside it, which Cassini was for 13 years, the coherence becomes something else. The number of distinct things to observe, the number of distinct surfaces to map, and chemical compositions to analyze and orbital dynamics to track, exceeded any single mission's ability to fully address. Papers are still being written from Cassini data. The dataset is not exhausted. Saturn, fully known, is not the right phrase. Saturn, attended to carefully for 13 years at close range, produced more open questions than it closed. The moons are part of that, Enceladus most obviously, and the question of what is happening at the bottom of that ocean, and whether that question is a biology question yet, or still just a chemistry question. It is still a chemistry question. It may not always be. What the winds are doing right now. The winds do not wait for anything. They are running right now, at this moment, while Saturn is on whatever side of its orbit it is on, while the hexagon turns at the North Pole and the rings lose their daily tonnage to ring rain. The equatorial jet stream is moving at somewhere between 1,600 and 1,800 kilometers per hour relative to the interior rotation rate, and it has been moving at approximately that speed for every moment Cassini was there, and for the decades of observation before Cassini arrived, and presumably for a long time before that, a time that extends back past any human observation program into the unobserved history of the planet's atmosphere. The jet stream does not have a source event. There is no storm that started it, no perturbation that initiated it, no point in the past at which a mechanism was triggered and the winds began. The winds are a feature of the planet, a consequence of its rapid rotation, its internal heat, the differential heating across its atmosphere. And they exist the way the planet exists, as a condition rather than an event, something that is the case rather than something that happened. Saturn rotates in approximately 10 hours and 39 minutes. One day on Saturn is less than 11 hours. For a planet 9 times Earth's diameter, this rotation rate creates a Coriolis effect, the deflection of moving air by the rotation of the planet beneath it, that is dramatically more powerful than Earth's. On Earth, the Coriolis effect shapes weather systems, bends jet streams, organizes hurricanes into their characteristic spiral shape. On Saturn, it organizes the entire atmosphere into the banded structure visible from Earth, the alternating eastward and westward jet streams that create the light and dark zones, the whole visible surface of the planet a direct expression of the rotation rate pushing the atmosphere around. The jet streams on Saturn are not analogous to Earth's jet streams. Earth's jet streams are relatively narrow, high-altitude rivers of fast air that weave and meander at altitudes around 10 to 15 kilometers. Saturn's equatorial jet stream is thousands of kilometers wide, possibly extends thousands of kilometers deep, and does not meander. It runs. The great white spots. Saturn produces, roughly every 30 years, which corresponds to one Saturnian year, a large convective storm in the northern hemisphere that becomes visible as a white spot expands dramatically and eventually wraps around the entire planet in a bright band before dissipating. These storms are not continuous features, they are events, periodic and violent, driven by the build-up of heat and moisture in the atmosphere over decades until convective instability triggers a major eruption of deep atmospheric material. The 2010 to 2011 storm was observed in detail by Cassini and by Earth-based telescopes, and it was large enough and lasted long enough to produce a lightning-producing thunderstorm that ran continuously for approximately 8 months. 8 months of continuous lightning. The storm eventually consumed itself. The expanding cloud material wrapped around the planet and collided with its own trailing end, disrupting the convective column that was driving it, and the storm quieted. The atmosphere gradually returned to something resembling its previous banded structure, though Cassini instruments detected an unusual warm region, a stratospheric vortex that persisted for years afterward. The next great white spot will appear by this periodicity around 2040. The atmosphere is building toward it now, quietly, in the way that a decade of relatively calm weather can be building toward the conditions that trigger a major event, except that the periodicity here is written into the physics of the atmosphere's heat cycle, and the cycle runs, and the storm will come. The thread of this chapter is duration, and it has been running underneath everything. The winds have been running for longer than any comparison from Earth's weather is useful. The jet streams that organize Earth's weather shift on timescales of years to decades. Saturn's equatorial jet has been stable at roughly the same speed for every year of observation. Not exactly the same. There are variations, but the same order of magnitude, the same direction, the same broad structure. If it has been this stable since Saturn reached its current configuration, then the winds have been running at these speeds for hundreds of millions of years. What would it mean to have been running for that long? Not metaphorically. As a physical fact, what does it mean for a process to have continued without interruption for a time that predates the dinosaurs, predates multicellular life, predates the formation of the Earth's moon? The process does not know how long it has been running. It has no memory. It is not old in any meaningful sense. It is just continuing, the way a rotation continues without any interior sense of duration. The duration is something we bring to it, not something it contains, and the duration is long enough that it exceeds any frame a human history can provide, and yet the wind is just wind, just pressure gradients and Coriolis forces and differential heating, just physics doing what physics does in a rapidly rotating gas giant with a strong internal heat source. It will still be running tomorrow. It was running before the first human being existed. Those two facts sit in the same atmosphere, on the same planet, right now. The sound it would make. There is a moment before the understanding, not before the explanation, before the thing itself lands. The moment when information has arrived but the weight of it has not yet distributed itself properly, when you know something and can say it back and it has not yet gone into the body where things go when they are actually understood. This chapter is about that moment, and it is happening right now as we consider what Saturn sounds like. It does not sound like anything. Sound needs a medium. Space has no medium for pressure waves in the conventional sense. A person in the space between Saturn and its rings would hear nothing. No wind despite the 1,800 km/h jets below, no roar from the planet, no creak from the rings, nothing at all. This is the threshold. Saturn emits radio waves. It emits them continuously, in a pattern that repeats with the rotation of the planet, modulated by Saturn's magnetic field interacting with the charged particles in its magnetosphere. The pattern is called Saturn kilometric radiation, and it was first detected by Voyager 1 in 1980, and it has been studied since, and it is real, and it carries information about Saturn's interior rotation rate and the dynamics of its magnetosphere, and it has been converted by shifting the frequency range into something human ears can detect into audio. The audio sounds wrong, not threatening exactly, not like anything else. A shifting, crackling, rhythmic pattern that has no analogue in any terrestrial sound environment, that repeats and shifts and intensifies and quiets on timescales that reflect the planet's rotation. It arrives here as a thought rather than a sound. Cassini was equipped to detect radio emissions. In its grand finale orbits, threading the gap between the rings and the atmosphere, it collected the closest measurements ever taken of this radiation. The data showed that the radio emission pattern, which had been thought to track the interior rotation rate cleanly, was actually more complicated, with different periods in the northern and southern hemispheres that shifted seasonally as Saturn moved in its orbit. The radio sound of Saturn is not a single rhythm. It is two rhythms, slightly different, varying with the seasons, which implied that the phenomenon generating the radio emissions was tied to Saturn's atmosphere and ionosphere, rather than directly to a solid interior, the way Earth's magnetic field rotation is tied to a solid inner core. This was a surprise. It changed the interpretation of what the radio data meant, and therefore changed the best estimate of Saturn's interior rotation rate, which had previously been derived partly from that radio data. The sound contained wrong information, or rather, the sound contained more complicated information than had been assumed. The sound was telling the truth, and the truth was stranger than the model. There is a specific quality to the Cassini audio recordings from the ring gap. The ring particles, trillions of individual ice chunks, from grains to buildings, all in continuous orbital motion, produce electromagnetic signatures that were converted to audio for public release. The expected sound, based on the predicted density of particles in the gap, was a continuous crackling, something like static. What Cassini recorded was almost nothing, very sparse impacts. The near silence of a region that should have been full, that near silence rendered as audio, is the quietest sound Saturn produced during the entire mission. The most expected noise did not come. The unexpected quiet did. There is an ongoing radio signal from Saturn's aurora that, converted to audible range, rises and falls with the auroral activity, with the pressure of the solar wind on the magnetosphere, with the dynamics of the charged particle environment. The aurora on Saturn is not visible to the naked eye from Earth. It occurs in ultraviolet and requires spacecraft instruments to observe directly. But it is happening. Right now, probably, depending on the state of the solar wind. Curtains of ultraviolet light at Saturn's poles, driven by charged particles spiraling down magnetic field lines and a radio signal singing its changes to any instrument close enough to receive it. The universe does not arrange itself into sounds we can hear. The range of human hearing is a narrow slice of the electromagnetic and mechanical spectrum, calibrated by evolution for the specific acoustic environment of one small planet's surface. Saturn's radio emissions, Saturn's auroral signals, the electromagnetic whisper of ring particles in orbital motion, these are all real. They were all happening before Cassini arrived to translate them. They will continue after the mission data is fully analysed and the papers are written and the dataset is considered closed. Saturn is loud in the register where loud happens. We are just not built to hear it directly. The translation is the closest we get, and the closest feels like a sound heard through a wall, present, real, shaped, and still carrying something that went through the conversion without coming out the other side, something that was in the original and is not in the translation, something that might not have a name in any frequency range we have language for, closer than Voyager got. The mission is over. Cassini is inside Saturn now, has been since September 15th, 2017, dissolved into the atmosphere it spent 13 years orbiting, its molecules scattered into a planet that will show no trace of the intrusion in any timescale that matters. The spacecraft that sent back more data about Saturn than all previous missions combined, that discovered the ocean under Enceladus and the full three-dimensional structure of the rings and the depth of the jet streams and the season-dependent rhythms of the radio emissions. That spacecraft is gone in the most complete sense of gone. The decision to end the mission this way was deliberate and considered. Cassini had run low on fuel. Without fuel to control its trajectory, it would eventually enter an uncontrolled orbit, and there was a possibility, over decades, that it could crash into Enceladus or Titan, both potentially harbouring conditions for life, both worlds that any remnant Earth microbes on Cassini's surfaces should not be allowed to contaminate. So Cassini was steered into Saturn. It was the cleanest ending available, and the scientists who made the decision had worked with the spacecraft for decades, and the last signal took 70 minutes to arrive, and by the time it did, the spacecraft had been gone for over an hour. The last data came from the mass spectrometer and the magnetometer and the other instruments that were running as Cassini entered the atmosphere. Some of the final samples were of Saturn's upper atmosphere directly, material that no instrument had ever sampled at that range. The spacecraft was doing science as it went, pulled back from the moment of entry. Cassini arrived at Saturn in July 2004 after a 7-year journey from Earth, having passed by Venus twice and Earth once, and Jupiter once to pick up gravitational acceleration. It carried the Huygens probe, built by the European Space Agency, which separated from Cassini and descended through Titan's atmosphere in January 2005, transmitting data for about 70 minutes during descent and for around 72 minutes after landing on Titan's surface, longer than expected, the surface being harder than some models had predicted. Huygens photographed rounded pebbles of water ice on Titan's surface, smoothed by liquid flow and a flat plane of darker material, and an orange sky, and then it ran out of power. Cassini continued for 12 more years. The grand finale began in April 2017, 22 orbits threading the gap between the innermost D-ring and the top of Saturn's atmosphere, a gap 2,000 kilometers wide that no spacecraft had ever entered. The navigation required to put a spacecraft through that gap repeatedly, at the correct angle, using tiny thruster firings timed to fractions of a second over a period of months, was itself a demonstration of what decades of orbital mechanics data from the mission had made possible. Cassini knew where Saturn's gravity would take it precisely enough to navigate a 2,000-kilometer gap at interplanetary distances. In those final orbits, the instruments found things. The ring gap was empty in ways that surprised the particle detector team. The magnetic field near Saturn was more precisely aligned with the rotation axis than any of the models had predicted, within a fraction of a degree, which was too aligned theoretically, because the level of alignment should suppress the dynamo mechanism that generates the field, and yet there it was. The atmospheric sampling detected molecular hydrogen and water vapor and organic molecules. The dust detector found that the material falling from the rings into the atmosphere was chemically complex. Not just water ice, but a mixture of organic compounds, the chemistry of the rings feeding directly into the planet's upper atmosphere. Pull back further. The solar system as Cassini left it. Saturn still running its winds, still maintaining its hexagon, still losing its rings at thousands of kilograms per second, still with Enceladus venting water from an ocean that may have hydrothermal vents at its floor. Everything Cassini documented is still happening. The documentation is done. The happening is not. What 13 years of close observation produced, beyond the specific data products, was a set of open questions more precisely formulated than the ones Cassini arrived with. Before Cassini, Enceladus was a small icy moon of uncertain geological activity. After Cassini, Enceladus has a global subsurface ocean, hydrothermal vents, and an active plume system feeding Saturn's rings. Before Cassini, the ring gap was unnavigated, expected to be hazardous. After Cassini, the ring gap is nearly empty for reasons still being worked through. Before Cassini, Saturn's interior rotation rate was estimated from radio emissions and assumed to be straightforward. After Cassini, the radio emissions reflect atmospheric dynamics rather than a simple interior rotation, and the true interior rotation rate is less certain than it was. The mission closed loops and opened others. The questions it left are better questions, more specific, more constrained, more clearly pointed at what would need to be true for the answers to be what they appear to be. Now zoom all the way in. September 15th, 2017. The last signal from Cassini arrives at the Deep Space Network station in Canberra, Australia, after 70 minutes of travel from Saturn. The team in the operations room at JPL, who have been there through the night, know the spacecraft is already gone. The signal is not news, it is confirmation, arriving after the fact, across a distance that made immediacy impossible from the beginning. The signal cuts out, not dramatically, not with ceremony. It goes the way signals go when the transmitter stops. The data stream simply ends, replaced by the background noise of the universe, which was there before Cassini and is thereafter, indifferent to the interruption. The team had been working with this spacecraft for between 10 and 20 years each, depending on when they joined the mission. Several of them had spent most of their professional lives with Cassini's data. The spacecraft was not a colleague in any real sense. It was a machine, an instrument package, a very expensive and carefully maintained collection of sensors and transmitters and processors. It did not know it had gone into Saturn. It had no experience of any of it. The signal ended, and the room went quiet in the specific way rooms go quiet when something has finished that will not start again, and what remained was all the data, still unanalyzed, still yielding papers, and Saturn, still running its systems, indifferent and patient and vast. The specific silence of the gap. The instruments were expecting noise. This is where it starts. Inside the expectation, before the data came back, when the model said the gap between the innermost ring and the top of Saturn's atmosphere should be populated with enough ring debris to register clearly on the particle impact sensors. The gap is 2,000 kilometers wide. It sits below the D ring, the innermost ring, which is faint and diffuse even by ring standards. Material should migrate inward from the D ring. The solar wind pushes charged particles. The drag from Saturn's upper atmosphere on ring particles in lower orbits should bring material down. The gap should have something in it. It had almost nothing. The first grand finale orbit on April 26, 2017, Cassini emerged from the gap and transmitted its data. The impact sensors had barely fired. The spacecraft had passed through 2,000 kilometers of near vacuum. The team used Cassini's large dish antenna as a shield on subsequent orbits, pointing it in the direction of travel in case the gap was denser than the first pass suggested. It was not. The gap was consistently, surprisingly empty. The thread, why? The leading explanation involves the way Saturn's magnetic field and atmospheric drag interact with ring particles at that altitude. Ring particles in orbits that close to Saturn experience significant drag from Saturn's outermost atmosphere. Drag that causes orbital decay, that would bring particles closer and closer until they enter the atmosphere. Any particles that migrate into the gap from the D-ring above would spiral inward quickly, removed by the atmosphere before they could accumulate. The gap is swept clean by the same processes that drive ring rain, operating faster and more completely at that altitude. The explanation is consistent with the data. It may be right. What it does not fully account for is how clean the gap was, cleaner than models predicted, even accounting for atmospheric drag. The models knew about the drag. They still predicted more debris than Cassini found. The gap was emptier than the best available explanation suggested it should be. This is where the thread gets thin. There is no dramatic mystery here. The data is not anomalous in a way that requires overturning existing physics. It is anomalous in the quieter way that data often is, where the model is broadly right but the magnitude is off, where something is doing more of what it should be doing than expected, and the reason for the extra doing is not fully identified. Papers have been written. The gap has been analysed from multiple angles. The combination of atmospheric drag and electromagnetic effects and the orbital dynamics of D-ring particles has been modelled more carefully. The gap's emptiness can be accounted for mostly within the existing framework. Mostly. The mostly is the thing that remains, not a crack, not a fault in the foundation. Just a small and persistent mostly, sitting in the data, in a 2,000 kilometre space between a ring and an atmosphere, where Cassini flew 22 times and found less than it expected to find, and the finding is not fully explained. The silence of that gap is a specific kind of scientific moment, not the silence of a mystery. the silence of an absence that does not quite fit the map. The map is mostly right. The absence is mostly explained. The gap between mostly and fully is where some of the best science happens, not in the dramatic departures from expectation, but in the small, persistent discrepancies that do not go away when you look at them more carefully. Saturn keeps producing these. The magnetic field too precisely aligned. The radio period that turned out to be 2 periods. The ring gap emptier than predicted. Small strangeness after small strangeness, emerging from the best observed planet in the outer solar system, each one tractable, each one being worked on, none of them settled into a complete account that closes the question entirely. And Cassini is inside Saturn now, unable to take any more measurements, having left the data set it left, which is still being worked through, which will be worked through for decades. Every answer reaching its own small edge of mostly where the fully has not quite arrived. The gap is still there, still empty, still doing whatever it is doing in the space between the ring and the atmosphere, sweeping itself clean by mechanisms that are understood and possibly by mechanisms that have not been fully written down yet. The instruments are gone. The gap goes on. A planet that is still settling. From very far back, before getting close to any of the specifics, the image is this. A planet that formed 4.5 billion years ago from a disk of gas and dust around a young star, accumulated its mass over millions of years of the solar system's violent early history and has been cooling ever since. Still cooling. Right now. Still. Saturn radiates more energy than it receives from the Sun. The ratio is approximately 1.78. Saturn emits roughly 1.78 times the energy it absorbs from solar radiation. The excess is not from radioactive decay, the way Earth's internal heat is partly from radioactive decay. It is from gravitational contraction, the slow settling of Saturn's interior under its own gravity, the gradual compression releasing energy that was stored when the planet formed, still being released now, 4.5 billion years after the formation ended. The process has a name, Kelvin-Helmholtz contraction. It was named for 2 19th century physicists who proposed it as the energy source of the Sun, a hypothesis that turned out to be wrong for the Sun, where nuclear fusion is the actual mechanism, but which is operative for Saturn, where the interior temperature and pressure are not high enough to sustain fusion. Saturn shines, faintly, on its own. Not visibly, not by radiating light, by radiating infrared heat, slightly more than it takes in, at a rate that has been declining gradually since the planet formed and will continue to decline as the interior cools and the contraction slows. There is a complication. Jupiter does the same thing, emits more energy than it receives, and the Kelvin-Helmholtz mechanism accounts for most of Jupiter's excess heat. For Saturn, it does not account for all of it. Saturn emits more than the contraction alone explains. The additional source is thought to be the differentiation of helium. Helium rain. Helium rain. At the temperatures and pressures in Saturn's interior, helium becomes partially immiscible in the surrounding hydrogen. It separates out, forms droplets, and falls toward the center of the planet, releasing gravitational potential energy as heat as it descends. The helium that was mixed into the outer layers when Saturn formed has been gradually settling inward for billions of years, each droplet falling a little, releasing a little heat, in a process so slow it produces no visible effect, no surface expression, Nothing detectable except the excess heat that comes out the other side. The evidence for this is partly in the excess heat and partly in the composition of Saturn's atmosphere. Saturn's atmosphere is depleted in helium relative to what the solar nebula composition should be. The primordial ratio of hydrogen to helium that Jupiter and the outer planets formed from. Jupiter is also depleted, but less so. Saturn is more depleted, which is consistent with more helium having rained out over the lifetime of the planet. The helium went somewhere. It went down. It is still going down. The contraction is real. The helium rain is real. Together they produce the excess heat, and the excess heat produces weather. Saturn's internal heat drives convection in the interior, and that convection, hot material rising, cooler material sinking, the same mechanism that drives Earth's mantle and the boiling of water in a pot, contributes to the winds. Some fraction of the energy driving those 1,800 km/h jet streams comes from the interior, from the heat that has been leaking out of Saturn since it formed. The winds are partly powered by the formation energy of the planet, still slowly releasing after 4.5 billion years. The winds are old in the sense that their energy source is old. They are the last ripple of something that happened a very long time ago, still going, still running at 1,800 km/h, still building the hexagon at the North Pole, still driving the convective cycles that will eventually produce the next great white spot. Saturn is quieter now than it was. When it formed, and in the early period of its existence when it was contracting more rapidly and generating more internal heat, it would have been brighter in the infrared, warmer, more energetic. The rate of contraction slows as the planet cools, which reduces the energy output, which slows the cooling slightly, in a feedback that extends the process over geological time rather than ending it quickly. Saturn will not finish cooling on any timescale that has a name a human would use, but it is further along than it was. The heat is less than it was. The contraction is slower. The helium rain continues, still falling, still releasing its small increments of energy, still slightly warming the interior against the cooling trend. Somewhere inside Saturn, at this moment, a helium droplet is falling. Not metaphorically, actually. A helium droplet formed where the temperature and pressure have passed through the threshold at which helium separates from the surrounding hydrogen, is falling toward the center of the planet, will arrive somewhere denser and warmer, will release its increment of potential energy as heat, and will blend into the surrounding material and cease to be a droplet. There is no way to observe this. There is no instrument that could see it. The evidence for it is in the atmosphere composition and the heat budget, and the evidence is good, and the droplet is real, and it is happening now in the way that all of Saturn's processes are happening now, continuously, without pause, without any awareness that this is the particular moment when a narration on a small planet far away has paused to note it. Saturn does not pause. It settles. It has been settling for 4.5 billion years, and the settling will continue, and the cooling will continue. And at some point, in a time that has no useful comparison, Saturn will be something different from what it is now, cooler and smaller, and with different winds and possibly no rings, and a helium-depleted atmosphere that has reached some new equilibrium. But not yet. Right now it is still warm enough, still energetic enough, still running all its systems at the rates they run, The helium is still falling. The heat is still leaving. The planet is still, in the most literal sense of the word, settling. It has not finished yet.